Alright, welcome back to my YouTube channel, Master Tutorials. We see where mathematics literacy begins. Alright, so now we are still on our BC 2022 solutions, section A, question 11. Alright, so it says arrange the following fractions from the lowest to the highest. Right, so what's a fraction? We can say that a fraction is an integer divided by another integer, or we can say that a fraction is part of of a whole. All right, so now we have proper fractions, which is 3/5, 1/4, then 2/3. How can we arrange these three proper fractions in ascending order, or from the lowest to the highest, or we can say that in increasing order of magnitude, or from the lowest to the highest, or from the smallest to the biggest. They are all the same thing here. So now here we have three methods here. You can find for the LCM so that you get the same denominators for this fraction, then use the numerators to do the comparison, right? Or you can change each fraction to percentage. You can get your answer. You use the percent to compare that. Or you can change each fraction to decimal fraction, right? These are common fractions, right? So you can change each common fractions to To its decimal fractions. So when you are done, you use the decimal fractions to compare them. I want to, you can sail through. All right, so now let's see how best we can solve this question. All right, so now let's continue. So I can change all to method one. You can say that change all to percentage. We are changing all to percentage. So I have 3/5 times 100, which is 5 here 1 is 120. So I have my 3 times 20, which is 60%, right? Then I have my 1/4 times my 100. So 4 here 1 into 100, which is 20. So I have my 1 times 20, which is 20 percent. Then my last one, 2/3 times my 100, 3 here 1 into 100, which is what? Oh, sorry. 3 cannot go into 100 exactly, right? 3 cannot go into 100 exactly. So now, better still, we have to multiply the numerators, then multiply the denominators. So we get 2 times 100, all on 3 times 1. So 2 times 100, which is 200, all on 3 times 1, we get 3. Then we use our long division to tackle that, right? So now here, 3 out, 200 in. So 3 goes into 20, 6 times 3 gets 18. We subtract, we still get our 2. Because 3 cannot go into 2 exactly, we drop our 0. 3 goes into 20, still 6. 6 times 3, we get 18. We subtract, we get our 2. Now 3 cannot go into 2 exactly, and here the values they are done. We are done with the values. We've consumed all the values. So we add our 0 to 8, then we bring our point. So 3 goes into 20 how many times? 6 times. 6 times 3, we get 18. Then we subtract, we get 2. So now we can see that we get 66.66666666. It continues, which is what? A recurring decimal. So we can see that this one is what? It's a rational function because it's a recurring or repeating decimal. So now we get what? 66.6, let's say 67%. We've approximated this one to what? To 2 decimal places, right? Or to the nearest hundredth. So we have 66.67%. All right. So now let's see how we can solve this. So now, since we change all to what? To percentages, we can compare them. So now, the lowest fraction or the lowest percentage here is what? 20, right? That's 20%, which corresponds to what? 1/4. Or you can start with 20%. Then we come to 60%. Then we move towards 66.6%. Now we have to take note that they didn't tell you to arrange this percentage here, right? They told you to arrange the fractions. So you have to take note of how you go by that. So you can see that hence from the lowest from the lowest to the highest, from the lowest to the highest is what? Is 20% is what? 1/4. Then 60% is 3/5. And we have 66.6%, 67% is 2/3. So 1/4 is 20%, 3/5 is 60%, then 2/3 is 66.66%. So we have this. So now we have it as 1/4, then it comes to what? 3/5, then it comes to what? 2/3. So which is what? Our option C. We have it as option C. Option C, which is very simple. Kindly watch it carefully. So our method 2, we are changing all to what? Decimal numbers. Still on question 11. We are changing all to decimal numbers. So we take 3/5. How can we change this one to decimal numbers? We can do our long division. Can 5 go into 3? No. Bring our 0, then 0.5. We go into 30, and we times 6 times 5. We get 30, right? Then we subtract. So now, then that means 3/5 is equal to what? 0.6. 3/5 is what? 0.6. Then we come to what? 1/4. 1/4 is equal to, we do our long division, 1. Now, can 4 go into 1? No. So 0, 0.4 going to 10 how many times? 2 times. 2 times 4, we get to our what? 8. We subtract 8 from 10, we get 2. Then now, 4, can 4 go into 2? No. So our 0, there is a point there, so we don't bring that again. So 4 into 20, we get what? 5. 5 times 4, we get what? 20. Then we subtract. So now we can say that 1/4 equals what? 0.25. 0.25. Alright, so 1/4 is what? 0.25, right? 1/4 is 0.25. 1/4 is 0.25. So we come to 2/3. So let's see for our 2/3. 2/3, which is 3 out, 2 in. 3 cannot go into that, so 0, then our 0 point. 3 into 20, which is 6. 6 times 3, 18. Subtract, which is 2, 0, then 6. Then still 18. So now we can see that 2 on 3 is equal to what? 0.66. So it continues as that, right? It continues as that. So we have 3/5, which is equivalent to 0.6 in decimals, 1/4 equivalent to 0.25 in decimals, then 2/3 is equivalent to 0.6666 in decimals, right? So now here, this one is a terminating decimal, repeating or recurring decimal. So I can say that they are all rational functions, or they are all rational fractions. Sorry, they are all rational functions. So rational fractions. So now let's see. We have 0.6, 0.25, then 0.66. So now, if you want to compare that, we can draw our place value chart, which we have, let's say, our whole numbers here, which we have, let's say, we don't have any whole numbers here, so let's see, we have our units, right? So our decimal point here. Then let's say our unit is the same thing as what? Ones, right? Then we have our tens, our hundreds, then our thousands. So we have our place value chart. So now we are representing this one. We have 0.6, 0.25, then 0.666, right? So now let's see how best we can solve this guy here. So now here, As you can check here, 0.25 is the smallest. Because if you compare to the tenths here, which decimal number is the smallest here, which is what? 2, which is 2, right? So let's see. All right, so let's proceed. So now here, 626. This one is the smallest decimal number here. So now we can say that 0.25 is the smallest. If you come here, here there is 0 here, right? 0, 0, 0. Then you can say that this 5 is the smallest. 5, sorry, 5 is greater than 0. Then 5 is less than this. But since the tenth here has what declared that you are the smallest, there is no need for you to ask for any argument because this one is 2. If here was, let's say, 7, then here is 2. Then still this one, we can say that this one is the what? 0.72 is the what? Is the biggest. But here is 2, then here is 5. So there is no argument here. Because this one is the smallest, then it tends to be what? 0.25 is the what? Smallest here. So now we can conclude that from what? From the lowest to the what? To the highest, we have what? We have 1/4 as the lowest fraction, right? Which corresponds to 0.25. Then you come to 0.60. So this guy is out. You come to 0.60. 0.60, 0.60, then 0.66. Now watch here. For the tenths here, we have 66. They are the same, right? They are the same. So now we pause. Then we move to the hundreds. Now here is 0, here is 6. Which one is greater? 6. Then we declare that 0.66 is greater than what? 0.60. 66 at the tenths area, 66 are the same. But we move to the hundredths area. Which one is greater? 6 is greater than 0. Then that means 0.66 is greater. So then this one is the smallest, another smaller decimal number, which corresponds to 0.6 corresponds to 3/5. And we have our last one, which is 2 on 3. So therefore, hence, we have 1/4, 3/5, and 2/10, right? 1/4, 3/5, and 2/10, which is very, very simple. So kindly watch it carefully. All right. So this one will be method 3. So we are changing all to what? Like fraction. Like fraction. So let's say 3/5, 1/4, then 2/10, then 2/10. We want to let these fractions have the same denominators, which is what? Like fraction. If they have the same denominators, they are like fraction. But here, they have different denominators. So the comparison will be very difficult. But you can use the inspection of the eye. You can get that. So now here, the denominators are not the same, so they are unlike fractions. Here, if you want to change all to like fraction, if you want to change all to like fraction, then you have to find for what? The LCM. You have to find for the LCM. The LCM. So now let's see. What would be the LCM of 5, 4, and 3? So now we can write 5, 4, then 3. Right. What would be the LCM for that? So now 5, 1, 4, 3. So we are using the successive division method. If you are using the successive division method, make sure that the numbers you are using to divide will be only what? Prime numbers. So now here 2, 1, 2, 3. Then 2, 1, 1, 3. Then 3, 1, 1, 1. Right? So we multiply all these numbers here. 5 times 2 times 2 times 3. 5 times 2, 10 times 2 times 3, 6 times 6. So 10 times 6, which is 60. So we have 60 here. 60. So now the LCM is 60. The LCM is 60. The LCM is 60. The LCM is 60. So I have my 60 here. So 5 into 60. 5, 12, 60, right? So now 5 will go into 60 how many times? 12 times. So I'll multiply the 12 by the 3. Then 4 into 60, 15 times. Because 4, 5, 20. Then we get that. 15 times R1. Then 3 into 60, we get 20. Then our 20 times R2. So 12 times 3, we get what? 36. Then 15 times 1, we get 15. 20 times 2, we get 40, all on our 60. So now we can see that we have 36 on 60, we have 15 on 60, we have 40 on 60. Right. So now we can see that they have the same denominators. They have the same denominators. So we can compare using their what? Numerators. We can compare using their numerators. So comparing using their numerators, you can see that which one is the smallest here? 15. So that's 15 on 60, which comes to what? 36 over 60. Then 40 over 60. Then 15 over 60 corresponds to 15 over 60 corresponds to 1/4. Then 36 over 60 corresponds to what? 3/5. And 40 over 60 corresponds to what? 2/3. So now we can see that indeed the three methods they what? They tally. They are very, very what? True for that. Alright, so still option 1/4, 3/5, 2/3. That's option C. Option C. So if you know that you shaded option B, you are wrong. Kindly watch it carefully. When you go to SHS, you do the same thing as that. It is very, very simple. That's real number system. Alright, so watch it carefully. Alright, so question 12. What is the length of the side of a square of area 225 centimeters square? 225 centimeters square. So now we have a square, all the sides are equal, right? So here is length, 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 length. So we are finding for the area, right? So now we know that the area of a square is length times length. You can see that A equals L times L, which is the same thing as L squared. So my A equals L squared. And we know that they've given us the area to be 225. So in place of this E, we can substitute 225, right? Which must be equal to L squared. So what do? You have to take what? The square root on both sides. So we have square root here, and here to what? Square root there. So this one takes away that. So square root of 225, you get 15 centimeters, which is equal to L. So therefore, the length of the side of a square is what? 15 centimeters, which is what? Option A, which is option A. So here we have 15.00. It's the same thing as 15.00 centimeters. It's the same thing. 15.00 centimeters. So kindly watch it carefully. Alright, so question 13. The rule of a mapping is x maps to 2x squared minus 1. What number does x equals to map to? Which is very, very simple. So they've given us the rule for that mapping, which is x maps to 2x squared minus 1. So what number does x equals to map to? So it means that x and 2, they are the same. So wherever I see x, I substitute in what? 2. So here there is x, so I substitute 2, which maps to, I have my 2 times my 2 squared minus 1. So my 2, which maps to 2 squared, which is 2 times 2 minus 1. So 2 maps to 2 bracket 2 times 2, 4 minus 1. then 2 mass 2, 2 times 4, 8 minus 1. Then 2 mass 2, 8 minus 1, which is 7. So therefore, the number that x equals 2 map 2 is what? 7. That's 7. So we have option C. That's option C. Option C for that. Watch it carefully. Let's go. Express 108 as a product of prime factors. So, which means that the factors of that 108, it might be what? Prime numbers, only prime numbers. And a prime number is a number that has what? Only two factors, 1 and the number itself, except 1, right? So now 108, we can use what? The factor tree, right? So now, all right, so with this, I can say that, okay, 2 will go into, let's see, I have my 108, 2 into 10, 5, then 2, 10, then 8, I have my 4, right? So we can use 2 into 50, 2 goes into 108, which is what? 54, right? Because 54 times 2, 2, 4, 8, 2, 5, 10, you get 108. All right. So we can proceed and use that one, right? Or someone can use, let's say, 3108. Can 3 go into 10? 3 times, then 9, then 1, then 3 into 18, 6. Let's see, 36 times 3, 3, 6, 18, 3, 3, 9 plus 1, 10. Somebody can still use what? 3. You can go through, right? So any number at all, you can go through, provided the number you are using can divide this 108 what? Exactly, you can use that. So now I can say that 2 then what? 54. Now 2 is a prime number because it has what? Only two factors, 1 and 2 itself. You understand that? Now here, we can use 54. We can proceed, then go further. 54. 6, 9, 54, right? 6, 7, 42, 6, 8, 48, 6, 9, 54. So can use 6, 9, right? 6, 9. Now 6 is not a prime number. Likewise, 9 is not a prime number. So we go further. 3, 2, 6. You circle that. Then 9, 3, 3, 9. You circle that. So if you are expressing 108 as a product of prime factors, then we have 2 times 2, then we have times 3 times 3 times 3. So we can say that we get 2 squared times 3 what? Cubed. So we have this, right? So which is the same thing as option 2 squared times 3 cubed, which is option D. Option D. Option D. So kindly watch it carefully. All right, question 15. That's our last question for this tutorial. So express 15 to 12 in the form 1 to n. So now, if you want to express that, this 15 to 12 can also be written as 15 over 12, right? So we can reduce that. Now let's see. 3 into 15, we get 5. Then 3 into 12, we get 4, right? So we have 5 divided by 4. So 5 divided by 4, but they are saying that they want it in the form 1 to n. 1 to n. So now let's see. This 5 to 4 can also be written as well. 5 to 4. 5 over 4 can also be written as 5 to 4. Now, if they want it as what? 1 to n, the first value should be 1. Then the second value should be n, where n is what? Is a number, right? So then we can say that then we should divide this one by 5, which is to 4 divided by 5. So that this one here, 1 into this 1. Then we get 1, 2, 4 over 5. So we have this. So now we can say that 4 divided by 5, which is 5 out, 4 in. Can 5 go into 4? No. So 0, 0 points. So 5 goes into 40. We have 5, 8, what? 40. So 8 times. 8 times 5, we get 40. Then we subtract. So then we can say that 1 to 0.8. Where our n is equal to what? 0.8. So we have that. So now we've expressed 15 to 12 in the form 1 to n, which is what? 1 to 0.8. Very, very simple. Very, very simple. So kindly watch it carefully. So our option will be what? Option D. Option D for that matter. Option D. Option D. Option D. Alright, so we'll end our tutorial lessons here. Master tutorials where mathematics literacy begins. Alright, do all to like my channel, subscribe, and share. When you go to Facebook, we have what? Master tutorials. YouTube, master tutorials. TikTok too, we have what? Master tutorials. So TikTok is what? At master tutorials. Do well, let your siblings sit down. Those who are in J1, J2, J3, even class 6, class 5, they can sit down and watch these tutorials and they will get the understanding. With God, all things are possible. Mathematics is not difficult. Do you understand that? All right. So we can say that mathematics is not a spectator or sport. So kindly sit down and learn. You will sail through. Have a nice day. Bye bye.